we now want the fastest decreasing direction, okay? Since the gradient direction is the fastest increasing, the negative gradient direction is the fastest decreasing direction. And actually, this is at the heart of all these machine learning, deep learning algorithms. When we train all these parameters of large language models, those have like billions of parameters. And you have to tweak those numbers so that the accuracy is the best. So error rate goes down. So you're trying to decrease the error rate by tweaking these billions of parameters. So it becomes a real problem to know which one to change in which direction. And by using this idea of gradient descent, people are able to make that work. Okay, and you know that history that's called the idea of backpropagation. And when the computers came out, for a while people didn't know how to do that. And some person wrote down the idea for his thesis, but then people forgot about it, and later on, some other people found it out. But even after finding out the method of gradient descent to train these machine learning models, it wasn't until later in the 2000s when they figured out, oh, I can use GPU to train these machine models. And after that, it's old history. The world is changing fast due to this. Gradient descent. All right, so let's try this one. First, you have to find the gradient, which is, if you differentiate this by x, is 4y squared. If you differentiate this by y, this is 8xy. So if you plug in 2 comma negative 1, negative 1 goes into y, 2 goes into x, negative 1 goes into y, which gives you 4 comma negative 16. Okay? And therefore, u hat is going to be the normalization of this vector 4 negative 16 over square root of this size 4 squared plus negative 16 squared. That's 16 and 256. Okay, so we could carry on the calculation, but we can also try this out. See, this is 4 times 4, right? So instead of just trying this, think about it this way. 4 squared plus 4 times 4 squared is, right? Rewrite that. Okay. This is 4 squared times 4 squared, so you can factor a 4 squared out. If you factor a 4 squared out, you get 1 plus 4 squared. Is that right? And that means this can get outside the square root as just 4, and what's left inside is square root of 17. And that means u hat is equal to 4 negative 16 over 4 times square root of 17. Okay? Now you don't have to do it this way. You can use a calculator and figure out that indeed the number that you get is divisible by 16, and you can factor the 16 outside the square root to give you 4. You get the same result. I'm just showing you a different way. But then, because these are both divisible by 4, you can say this is 1 comma negative 4 over 4 times square root of 17. So that's the answer to part A. Oh, is that the A? It's not, right? What's the correct answer? I made a mistake. What? What kind of direction would this give you? The fastest increasing direction. Fastest decreasing. So what do you do? Negative. Negative. So that's going to give you negative 1.4 over 4. That's what it is. Okay? Okay, and then part B, du hat f negative 2, 1 is equal to gradient of f dotted with u hat. But we could use this one and do a dot product with that, but that's just waste of time. You can do it much simpler by rewriting this as norm of gradient of f times the norm of u hat times the cosine of, if you have two vectors that's directly opposite of each other, what's the angle between them?
180.
180. 180 degrees. Okay? Because that's the definition of a dot product, right? What's the norm of this? Oh, it's this one, right? It's 4 square root of 17. Yeah, we were doing this one, which was the norm of this vector on the top. What's the norm of u hat?
1.
1. What's cosine 180?
-4.
Negative 1. So the answer is negative 4 square root of 7. Okay. Now, if you are not so confident that you can do such a thing, then take time to do the calculation. It's not too bad. Then you can multiply, you can do a dot product of this one with this one. Oh, I don't know why nobody told me this. That's wrong. Okay. This is the correct answer. 4 canceled away, so that 4 no longer should exist. Yeah, so that's the correct answer. But this doesn't change. Okay, so try this one. You do the dot product between this one with this one. Then if you calculate that, you're going to get that exactly. Okay.